locations, as Kathy said, that have some sort of porosity or space between the grains in the rock. There's actually void space or pore space. And so you have to have a suitable rock for that to happen. And again, over at the booth, I have some great examples of that, and we actually have a hands-on demonstration where we can show you how air can actually move through these rocks. And then, as I mentioned, there's also the option of using CO2 for enhanced oil recovery. The nice thing about CO2 is it actually dissolves the oil and then swells that oil and helps push it out of the pore spaces where that oil is trapped. So CO2 is a great solvent for enhanced oil recovery. And really, in order to keep the Bakken going strong, we need that. We're leaving a lot of oil in the ground. Estimates from industry producers or, some are optimistic and say, yeah, well, we recover 15%. I think on average it's probably closer to 10, but we're leaving a whole lot of oil in the ground. So this CO2 provides tremendous opportunities for enhanced oil recovery. Okay, so now this video should work. Now I want to show this video because it's a great example. Even though he's talking about oil, this is very much the way CO2 behaves in the subsurface.
Through ice reservoir rock, crossing the permeability, moves up until it reaches a rock that is no longer molded. The pores aren't connected. Fluid and gas cannot move between the pores, and that rock has low permeability.
Those tightly closed rocks are called seals or cap rocks.
Okay, so just as many of our conventional oil reservoirs, that's how they formed. The oil was trapped by what we call a seal or a cap rock that doesn't allow fluid or gas to migrate through that rock. Those are the same types of seals that we need on top of any of our CO2 storage reservoirs. So you have to have a layer of impermeable rock to prevent that CO2 from migrating. Now these seals, they've held oil and gas in place for millions, hundreds of millions of years. So we know that they are very effective at containing the CO2. So why, again, why is there so much interest? There's actually a lot of incentives right now for CCS-related projects. So there are federal tax credits. Federal tax credits for, they're called 45Q tax credits for use in both just the dedicated storage, so the permanent storage in a saline formation, a salty formation, where you just sequester it permanently. And there's also tax credits for using it for enhanced oil recovery, where at the end of the day, you're still permanently sequestering about 95% of that CO2 in the ground. So even though you're using it for enhanced oil recovery, it's still sequestration. So you can see the tax credits. If you're capturing it, say from a power plant or spent plant, for permanent storage in a saline formation, it's $85 a metric ton. And for comparison, a metric ton or ton is about 1.1 US tons or about 2,200 pounds. If you're using it for CO2 enhanced oil recovery, it's about $60 a ton is the credit. If you're directly capturing it out of the atmosphere, so that's called DAC, the credit is much higher, so $180 a ton for permanent storage and $130 for EOR. There's also these West Coast low carbon fuel standards. So in California, Oregon, Washington, they will pay a premium for ethanol, where the CO2 is during that ethanol process and when it's being produced. If you capture that CO2 and permanently sequester it in the ground, there are premiums for that ethanol, which actually will benefit not only the ethanol facilities, but the farmers who are growing the corn. This should look familiar. So Kathy did a great job explaining what this cross-section looks like. So again, the western part of the state all the way over to the eastern part of the state. And I just want to point out some of the potential opportunities for CO2. So I have the Fox Hills on here. That's the deepest underground source of drinking water And they are very careful whether you're drilling an oil and gas well or a CO2 storage well, very careful to put extra layers of protection in place through those zones to ensure that you're not going to contaminate any sources of drinking water. Potential CO2 storage targets, we have the Indian Car Formation. Many of you may know that as the Dakota sandstone. That's the #1 target right now for saltwater disposal. The Brook Creek, that one's the one that's been most heavily targeted for CO2 storage. But then we also have these opportunities for enhanced oil recovery. So again, everybody's heard of Bakken. But we have many other, again, conventional oil reservoirs that can benefit from enhanced oil recovery using CO2. And then I didn't point out the deadwood, but the deadwood at the very bottom is also a potential CO2 storage target. But again, it's really been the Brook Creek that's been the focus for many projects. So where are the active or planned projects in the state? As Kathy mentioned, Dakota Gasification has been capturing CO2 and piping it up into Canada for over 20 years. They also recently, though, started, actually back in February, they have their own project where they're taking a portion of that CO2 and permanently storing it underground. That is the largest operational CO2 storage project in the world. And it's right here in the state. Denbury, so you see in the bottom left of that map, Denbury, for over 2 years now, they've been taking CO2, transported from Wyoming, and injecting it for enhanced oil recovery in a conventional oil reservoir, actually several conventional oil reservoirs. So it's already being done here in the state. Some of the other ones, Blue Flint and Red Trail. I wish I could figure out how to get the pointer to work. But those are ethanol plants. Red Trail's been injecting for over 2 years now. Blue Flint has been injecting since last October. So we have projects they are occurring right now. There's some others that are planned, like DCC East and DCC West. That's Dakota Carbon Center. That's associated with Dakota Power. That's in the works. We have, you've probably heard of Summit. They're planning on building a pipeline, capturing ethanol from facilities throughout the Midwest, bringing it up to that location for permanent storage. We also have Prairie Horizon. That's a partnership between TC Energy and Marathon Petroleum. They're looking at a CO2 storage project. And then we have a couple, Rough Rider Hub and Sarah. So there's a lot in the works, a lot that's already active. So who regulates this? So we're fortunate enough to get what we call primacy in the state of North Dakota for regulation of CO2 storage wells. We were the first state to get primacy. We are still only one of 3 states to have that primacy. Wyoming and Louisiana are the other 2. Our rules for permitting these wells are as stringent, and in some cases more stringent, than the federal regulations established by the EPA. So there's a whole slew of things you need to evaluate and prove before they will even review it and approve your permit. You have to do a detailed evaluation of the subsurface geology. You have to estimate, where you think that CO2 plume extent will be in the affected pore space. You have to ensure that the well casing and cementing, everything, is solid, and you have all the necessary protections in place. You need a testing and monitoring plan, emergency remedial response plan, and you can see it all. It's very rigorous, this process for getting a CO2 storage facility permit approved. And in general, so there's lots of questions about the safety of CCS and CO2 and concerns about CO2 pipelines. So CO2, not to be confused with carbon monoxide, because I have heard cases where folks are thinking we're talking one and the same. This is not carbon monoxide, this is CO2. It's a colorless, odorless gas that, as many of you know, it exists. We're surrounded by CO2. I mean, it's in our fire extinguishers, in our carbonated beverages. We exhale CO2. So it's around us. It's not explosive, not flammable. It's actually been safely transported in the U.S. since the 1970s. There's currently over 5,000 miles of CO2 pipelines in the U.S. I've also heard some concerns about the pressure in these CO2 pipelines. So, you know, the projects, they typically pipelines operate at pressures ranging from 1,100 to 2,200 PSI. For comparison, the pressure in a fire extinguisher or in a paintball gun is about 800 PSI. So it's a little higher, but certainly not. I've heard numbers that are much higher than this, and that's not accurate. So this is the map, doesn't show up so great, but the green color on there, those are either existing or planned CO2 pipelines. So what are the benefits of this? For one, we have folks like the state of Minnesota who are demanding low carbon electricity. We supply a huge portion of Minnesota's electricity from our coal-fired power plants. If those coal-fired power plants are able to implement CO2 capture and storage and offer that low carbon electricity where there are market demands for it, that helps ensure that our coal-fired power plants stay operational, that our coal mines stay operational. As I already mentioned, we need that CO2 for enhanced oil recovery. Some people may look at CO2 as a bad thing. We look at that as a necessary thing to keep our oil and gas production going. And again, not just in the Bakken, but in our conventional oil and gas reservoirs. And again, these low carbon fuel standards, that's a tax incentive for the ethanol facilities, for corn growers that they can capitalize on, and those credits, you know, and those markets currently exist. So, with that, thanks for your time and attention.